amazing Australians and the story of their lives. You're tuned to Lots to Chat About with Rosemary Peterswald.
Hello, listeners, and welcome. My guest today is Professor Ian Henderson, the Executive Director of the Institute of Molecular Bioscience at the University of Queensland. In this role, Professor Henderson is responsible for developing the research strategy of an established world-leading research institute with over 500 staff and students, fostering collaboration and raising the profile of the institute and the university internationally. He is a Professor of Microbiology and completed his Bachelor of Science honours at the University College Dublin and his PhD at Trinity College Dublin. He also holds a postgraduate certificate in teaching and learning in higher education from the University of Birmingham, and he is a Fellow of the Royal Society of Biology. Professor Henderson has published over 150 research papers, reviews and book chapters, and his publications have been cited over 15,000 times with an average of 100 citations per paper. He has devoted much of his working life to study antibiotic resistance and the ability of microbes to resist treatment and develop solutions to this urgent global challenge. Welcome, Ian.
Thank you, Rosemary, and thank you for having me on.
It's an absolute pleasure. I'm obviously no expert in molecular science, and I'm sure many of our listeners aren't. In fact, as I said, until I met you a few months ago, it hadn't really crossed my mind much. Can you tell me a little bit more about it, what it is exactly, and how you sort of fit into it there?
Probably good to start the conversation with sort of understanding the impact that infection has on people's life expectancy. So if you grew up in 1910 in the US with an advanced healthcare system, the average life expectancy was 50. Now, up until 2020, that had grown from 50 years of age to 79. And if you think about the three big impacts on extending life expectancy over that time, were clean drinking water, antibiotics, and vaccines. And so vaccines you are predicted to give you about 10 years of additional life expectancy. Antibiotics and clean drinking water about 15 years of additional life expectancy. Right. And so if you put that in context,
yes,
every other medical intervention that we have gives you 4 years of life expectancy.
Right.
So it's remarkable.
Yes, absolutely. You grew up in Dublin.
Yeah.
You went to the Christian Brothers School of very hard knocks, I think, wasn't it? Tell us a little bit about that. You were a close-knit family, and tell us what the Christian Brothers were like and living in Dublin at that time.
I grew up in Dublin, as I said, a family of 5 kids. I have 2 brothers, 2 sisters. I'm the second oldest. I have an older brother. Did indeed attend the Christian Brothers College, and it was, as you said, the school of hard knocks.
Very hard knocks at times. Now, tell me, I believe your brother suffered from bipolar. How did that affect your youth and growing up?
Look, I would say 3 things about my older brother. He is immensely artistic, fiercely defensive of the family, really deeply loving. But, he does suffer with mental health. He's got bipolar disorder, and that wasn't diagnosed until his 20s, his early 20s. And so I don't think growing up, we didn't have a diagnosis. We knew, he was a difficult child or whatever.
Yes.
And actually, I think actually being able to put a name to it when he hit his 20s was immensely helpful and liberating for the family, because we sort of then understood what was happening.
Exactly, and that makes it just that little bit easier to cope with. Mm-hmm. But now tell me, where were you when you suddenly thought, I will become an expert in molecular science, and in particular the role of microbes and antibiotic resistance? I think you said you were a little bit of a daydreamer at school, but you had a biology teacher that got you very interested.
You're absolutely right, Rosemary. And I often think about, if I talk to my colleagues, most of us have, to become a scientist, have had that person that inspires us to do what we did, that sort of opened up the the possibilities, the questioning to actually become scientists. So I was indeed a daydreamer in school. I arrived at sort of finishing my leaving cert, not really knowing what to do. We didn't have a history of university education in the family. My father was at sea. My mother was a secretary. Nobody had come before me that had gone to university. And so I was thinking about what I was going to do. And I was studying biology for the leaving cert.
Yes.
And if you study biology in Ireland at the time, the only microbiology you learned about was the potato famine.
Exactly. That's right, yes.
And I was always fascinated by the fact that something so small could have such an impact, on global history.
Exactly.
Not many people know that actually the population of Ireland and England in 1840 were about the same. Right? About 9 million people. And then by 1950, 100 years later, the population of England had grown to 30 million, but the population of Ireland, in the Republic of Ireland, had dropped to just over 2 million by 1950, 100 years later.
And that wasn't necessarily totally by death, because there was a huge amount of immigration around the world, and nearly every country in the world has benefited from the Irish coming.
And that's absolutely right. Australia wouldn't be what it is today without actually having that Irish potato famine, with all the people that came here, or the US, largely influenced by the immigrants from Ireland.
Yes. You went to Trinity University, or Trinity College, I should say, in Dublin. What was that like? I once went there with my father and walked through, and the students looked to be having a ball. They were all running past, and scarves wrapped around. It was very cold around the head, but they looked as though they were having fun. Did you enjoy it?
Oh, I loved Trinity. It was a great period of time. We had a fairly close-knit group of PhD students within the department that I worked in, the Moyne Institute, which is based in the corner of the rugby pitches on campus, and the rugby bar was right next door, the pavilion. And so we had a ball of a time. They were great people, really intense, connection around thought and process, and, thinking about problems and solutions to problems at the molecular level.
And you played rugby?
I played rugby university, undergraduate. I didn't play it through postgraduate. Went back to playing it for one season when I was working, and got a few injuries, and said, I'm a bit too old for this.
Right. But you certainly enjoyed your time growing up and being educated in Ireland before it took you further afield.
Absolutely. I talk to my kids about this. I think Ireland has always had a deep connection to education and the, land of saints and scholars, right? We've always had a deep connection to learning, to education, to wanting to know more, and so I try to inspire that in my children is, ask questions, think about things.
And terrific. And that expertise, as we've said, has fortunately gone around the world to the benefit of the world. But now, going back a bit further than that, in 1928, Alexander Fleming discovered penicillin in an extraordinary way. Can you please tell us a little bit more about that?
Well, I can tell you the story about penicillin, and the story that we all know is Alexander Fleming. Yes. He goes off on vacation, and he leaves his agar plates on the bench and comes back a few months later, and notices, there's this fungus growing on the plate, and it's killed all the bacteria that were on the plate. And he went, that's, a eureka moment for him, where he goes, okay, if that organism is killing all these bacteria, it must be producing something. And so what is the thing that is producing it? But Alexander Fleming wasn't the first person to notice that phenomenon.
Oh, who was?
So there's a guy called Ernst Duchesne, a French physician back in the 1890s, who had made the same observations around extracts of penicillium, the fungus, being able to kill bacteria. But he wrote up his thesis, submitted it, and it never got recognized by the Pasteur Institute. So it sort of faded into the background. But the other thing is, while Alexander Fleming was credited with the discovery of penicillin, he never actually had the spark that said this could be used for treatment of human infections.
Right.
He actually didn't think it could be.
Yes.
And what he was using it as a tool in the laboratory to actually suppress the growth of bacteria for things like when you were making vaccine components, etc. And it was an Australian, Howard Florey,
Of course.
who'd moved to Oxford as a Rhodes Scholar,
Yes.
that actually made the connection. Oh, well, and it was about a decade after Alexander Fleming's discovery, but he saw Ernst Duchesne's work and he saw Alexander Fleming's work and made the connection. We could actually use this, actually whatever the compound is that's being produced by this fungus,
Yes.
and purify it and use it to treat patients who have infections.
And who was that first patient to be treated, and what was he treated for?
He was a policeman and his name was Albert Alexander.
Right.
He was an avid gardener and he had pricked his finger on a rose bush in the garden and got an infection. And so Florey and another chap he teamed up with, Chain, were able to produce some of this penicillin and give it to this policeman. And his infection resolved, but they ran out of penicillin. And so what they were doing was they were actually taking his urine and repurifying the penicillin from his urine to try and get enough to continuously treat him. But while they noticed improvements, they didn't have sufficient to actually cure him.
Right.
And so he eventually passed away.
Right.
And so then the idea then was that they could scale up the production. But this was wartime UK.
Yes.
And so they didn't have the capacity in the UK to do that. So Florey, Chain went off to the US and they worked with the US to actually produce penicillin en masse, so large scale.
Right.
And so then within just a couple of years, penicillin was being used, by the Allies.
Isn't it
throughout the war.
extraordinary? It just made such an enormous difference to the world, really, didn't it?
Yeah.
Incredible. You're listening to Lots to Chat About. I'm Rosemary Peterswald, and my guest today is Professor Ian Henderson, who is Executive Director of IMB at the University of Queensland. Now, you've said that prior to COVID-19, which changed the entire world again, people had forgotten or didn't know the impact that microbes continue to have in communicable diseases. The infections that we normally associate with microbes, but said that many of us don't know, is the role microbes play in non-communicable disease, i.e. sort of diabetes, cancer, stroke and heart attacks. Can you explain a little bit more about that? I mean, how does one know if you have a particular microbe?
Look, I think that's a very complex question, Rosemary. Look, I think what you can think about is direct infections, like getting COVID
Yes.
or getting strep throat or
Right.
whatever. There are, lots of those infections that occur.
Yeah.
There's roughly 13 million deaths a year from
Yes.
infectious diseases. But then you've got a whole bunch of non-infectious diseases that people die of, that most
Yes.
people in the world die of heart disease, some,
Yes.
stroke or heart disease. Only about 10% of people die from cancer. And then there's diabetes, etc.
Yes.
Not without giving you the breakdown of the percentages. But microbes have a big impact on those non-infectious diseases. So there's particular ones like cystic fibrosis,
Right.
okay, which is a genetic disorder.
Yes.
And in that genetic disorder, you can't move mucus off your lungs, and bacteria can get into the mucus and start to grow.
But Ian, can I just interrupt there for a sec? We had Reggie Bird on, who won Big Brother twice. Now, her son, sadly, was born with cystic fibrosis. And it turned out that herself and her husband carried a gene for that. So what's the difference between a gene and a microbe, really?
Well, genes would be the bits of DNA within you
Yes,
that
yep.
That actually make up your cells, that
Yeah.
tell you your body how to function. But a microbe is a small independent organism. It's got its
Yes.
own genes that can live on you and in you. There's actually more microbial, bacterial
Right.
cells in and on your body than there are human cells.
So the gene was there first.
Genes would
Well,
have to come. So microbes are,
Yes.
ancient sort of life forms, eventually giving rise to go
Right.
through evolution to higher
Right.
order,
Right.
I guess.
It's fascinating, isn't it? Because as my listeners would know, I was diagnosed with cancer last year. And of course, one goes round and round and round in your brain. What caused it? Was it the sprays in Papua New Guinea? We all had an orchard once and we used sprays. Or did my mother have a gene or whatever? But now you're telling me it could be a microbe, I suppose.
Look, microbes are associated with certain cancers. So gastric cancer is associated with the Helicobacter pylori.
Yes.
So there are certain infections that can drive cancer. But actually, the real connection, I think, what we think about these days is the resistance of bacteria to antibiotics.
Yes.
Because the thing that keeps people alive, and you probably know, through sessions of chemotherapy, through surgeries, is actually antibiotics. We give antibiotics prophylactically to suppress infections. And with the rise of antibiotic resistance, then that actually threatens, our ability to treat cancers, to have open heart surgery, to have stents, etc.
Right, right. And as you say, I mean, one of the scary statistics that's often quoted is if we don't take action and develop new strategies to combat antibiotic resistance, 10 million people per year will die. That's sort of the statistic I read, to drug resistance infection by the year 2050. So that's an addition of 12 million who die each year of drug-sensitive infections. But that's it's a scary prognosis, isn't it?
Yeah, look, that work that you're talking about was not actually done by or led by a microbiologist. It was actually led by Sir Jim O'Neill.
Right.
Who's an economist, and he was hired by David Cameron to actually study the impact of antimicrobial resistance on life expectancy and also the economy. And what he projected was that up to 10 million people a year would be dying of antimicrobial resistant infections by 2050.
Right.
Now, that's not of all infections.
Yes.
That's just antimicrobial resistant infections. There are other infections that will still be susceptible. Now, a lot of people sort of poo-pooed that number.
Yes.
But we had a publication only a month ago that studied that, and we're already halfway there. It's 4.9 million people died in 2019 of antimicrobial resistant infections.
Are we being prescribed antibiotics too much, sort of willy-nilly? You go to the doctor, you've got a cold, you've got a sore throat, here. Well, perhaps not even quite so much now, but certainly in the old days, here's a prescription for antibiotics, go off to the chemist and you should be right.
You're right. It's a multifactorial. It's a very complex problem. Part of that is the overuse and prescription of antibiotics.
Yes.
So you going into your doctor and getting a script for a viral infection, and that antibiotic won't have an effect.
Right.
Because it's a virus, right? They only kill bacteria. And so by taking those antibiotics needlessly, you're putting those antibiotics into the environment, you're affecting the bacteria that grow in you and on you, and those get transferred to other people, and in doing so they can become resistant, and then you can pass on that resistance.
What are we going to do? Are we going to be able to find an antibiotic that is not totally resistant? I mean, I think you said, or somebody said to me, that the huge pharmaceutical companies are not quite so interested in developing an antibiotic that's resistant as they are to a cure for cancer or whatever, because there's not quite as much money in it. Is that true?
That is absolutely true. If you think about the return, and again, it's a very complex issue, but we're kind of addicted to cheap antibiotics. You know, you go to the pharmacy, you get a penicillin, like, you know, prescription for your sore throat. It's,
Yes.
you know, it's $5 or whatever. But a cancer drug is, you know, can be 100,000. It could be 200,000 drugs for a course.
Yes.
Okay. So of course, then there's and it's used over a longer time period than, say, the 4 or 5 days of an antibiotics. And so you can see already the monetary driver for pharmaceutical companies,
Yes.
you know, investing in cancer therapeutics rather than antibiotics.
What are we going to do? You certainly need more funds, don't we, to be able to take it further and see what we can do to find an antibiotic that will be resistant.
Look, I think there's the solution is probably as complex as the problem, Rosemary.
Right.
It's, you know, if you think about just improving access to antibiotics, to vaccines, and tackling the most problematic infections, you know, you're looking at an estimated 90 to 100 million lives saved
Right.
over the next 30 years.
Right.
Okay? But actually finding those is going to be difficult. So there's a couple of things we can do. We have to keep looking for new antibiotics.
Right.
And the domain for that is primarily going to fall to universities, you know, research organizations funded by the government to actually develop those. And there's some really wonderful international efforts to do that. You know, the CARB-X, which is a funding body in the US that funds this type of work. And that's supported by the Wellcome Charitable Trust and Novo Nordisk and British government, etc. But there are other things we have to think about is the use of vaccines.
Yeah.
So, because if you can vaccinate and prevent an infection from happening in the first place, then you probably won't want to use an antibiotic.
Yes.
Right? So there's different ways that we have to tackle it, but it is going to require more investment.
Now, Ian, how did a young fellow sitting in Christian Brothers in Dublin and dreaming of, daydreaming, as you said, but how did you end up here now in Brisbane with your beautiful family? And you didn't come directly, I know, from Dublin to Brisbane. There was sort of a roundabout way, wasn't there, getting here?
Yeah, so I grew up, and I don't know if I told you this, but I grew up in a suburb of Dublin called Blackrock.
Oh, yes, that's right. Yes, yeah.
And I then went for my first job to the Wellcome Trust, and this was back in 1990, working on HIV.
Yep.
And so that was in Beckenham in Kent.
Yes.
Then I went to the US to work at the Centre for Vaccine Development in Baltimore, USA.
Yes, right.
And my first posting was back to, from there was back to Belfast.
Right.
And from Belfast, I went to Birmingham.
Yes.
And from Birmingham to Brisbane.
Oh,
So
right.
I only live in places beginning with the letter B.
Oh, really? Well, apart from Dublin.
Well, it was Blackrock and Dublin. So, but how did I get that? So I finished my PhD. I went off to work, as I said, the Centre for Vaccine Development in the US. Spent a wonderful 4 years there. It was really, really enlightening, going to an environment that had much more capacity to do research than we did in Ireland.
Right.
And that it was a great crucible for learning. Right?
Yes.
And from there I went to Belfast, but I only stayed in Belfast for a very short period of time before I got recruited to the University of Birmingham. And, you know, I landed in Birmingham with my wife, US wife.
Well,
I managed to steal one from the US.
I know, you found something very important in America. Yeah.
Indeed. And you know what? I think we went to the UK thinking we would only be there for 3 or 4 years.
Yes.
And then, you know, life catches up. You've got my firstborn beautiful daughter, Emma, and then the second daughter, Katie, comes along, and they're just, amazing kids. And you begin to deal with life and the mortgage and getting them in school and whatever. And time goes by, right? And then all of a sudden we were in the UK for, 16, 17 years. And, we're thinking, what's next? And the opportunity came up here to come to Brisbane.
Wonderful.
And the thing that really attracted me to Brisbane is we had just developed a therapy for infections. Yes. And the Institute at the University of Queensland that I'm at now, at the Institute of Molecular, had a history and a reputation for actually developing therapies and putting them into patients.
Right.
And so I saw an opportunity to come here and leverage the expertise that was here to do the same.
Much to our benefit. Now, I saw a big sign up the other day in Sydney, I think it was, put up there by the Irish government asking their builders to come home to Ireland and help build Ireland, because all the builders have come to Australia and they love the warm climate and they like living in Australia. So Ireland's running out of builders. Is there such a placard going up for scientists, etc., that have taken their knowledge and that and gone to other countries like Australia? What do you miss about Ireland, I think, on what I'm coming to? And are you likely to go back? I mean, obviously, one of the hardest things, is when you do migrate, as I know, is you leave a lot of family behind in the country, in your home country. But you get back quite a bit, I think. But you think you're in Brisbane to stay?
I think that's our plan. University of Queensland is just an extraordinary place to work. I don't think many people, even in Brisbane, would know it's in the top 50 universities in the world. And the institute that I run is one of the top 5 or 10 research institutes globally. It's just a remarkable place to be. But then, if you're from Brisbane, you kind of know how cool the place is, right? The weather is fantastic, the people are fantastic, the environment is fantastic. Talking about Ireland, what do you miss? Yeah. It's people. It's always people. It's family. Yes. But I don't think I see myself ever. I'm longer out of Ireland than I was in it. Yes. But there's always that familiarity of going home, and I was discussing it. Science is a very global endeavor. Yes. 70% of the people who work for me are international. Right. Yeah. So it's a very global endeavor, and we have this conversation. When you go home, it's like you've been wrapped in a blanket of familiarity. From the moment you get off the plane and they say, welcome home. Correct. Yes. But once you've been there for a while, you realise you're actually a little bit disconnected. Mm-hmm. But I still love going home to get wrapped in that warm blanket. Exactly. It's hard to give up, isn't it? And I like to get home often as well, as we have. But the one thing Ireland has that Brisbane doesn't is a good log fire in a pub with a pint of Guinness in the middle of winter. That's exactly right, yes. And your daughters have really settled in. Your beautiful wife, Kathy, told me that they love living here. Mm-hmm. You were very, very lucky in Brisbane, in Australia, I should say, to have you here leading that wonderful department at the university. Thanks, Rosemary. Yeah. So I could go on chatting to you for quite a while, and I'm told that we have run out of time. So it goes very quickly, doesn't it? It does indeed. When you're having a good time. But Professor Ian Henderson, renowned scientist and Executive Director of Molecular Science at the University of Queensland, for being my guest today. And may I wish you great success in the continuation of your invaluable research here to antibiotic resistance. But just very quickly before we go, you want soil. Why do you want soil? Most of our medicines come from soil. Right. So like Alexander Fleming, where he found the penicillin, but you'll find that in the soil. Yes. So most of our medicines, they're produced by bacteria that grow in the soil. And so we isolate those bacteria and fungi, and we look for new chemicals that they produce, because they've been at it for billions of years. But do you want lots of people dropping soil off to the university, or have you got enough soil? We got no, can never have too much. So we have a program called Soils for Science, where you can just write in, you can Google it, Soils for Science at UQ, and we'll send you out a pack with instructions. You can dig up a little bit of soil, put it in a prepaid envelope, and send it back to us. And we will screen that for new. What do they Google again? Soil for. You could look up just Soils for Science at the University of Queensland. Soil for Science at the University of Queensland. There you go. You could have the next cancer drug in your back garden. Exactly. Thank you, Professor Ian Henderson. Thank you so much, Rosemary. And thank you, Paul, for producing.
Thank you. Great friends and great chats. That was another Lots to Chat About with Rosemary Peterswald. Stay tuned next week for another amazing chat.